Hey, so I want to give you the nice, quick, down and dirty way that I use to interpret ABGs. So I don't think ABGs are hard at all. I just think people don't have a good systematic approach. If you develop a systematic approach for anything you do, you're gonna get it every single time. Every single time. It goes the same thing for 12 lead EKGs and so forth. So I'm gonna show you what I do. Hopefully it works for you, and if it doesn't work for you, you're not gonna hurt my feelings, because we all learn differently. So this is how I learned, this is how it works for me, so hopefully it does work for you. So let's get to it. So obviously I don't have a lot of high-tech devices here with me, so I'm gonna use my notes, which are pretty awesome. So anyway, ABGs have three major components: pH, CO2, and bicarb. So pH is super important because pH drives the function of our hormones and enzymes and proteins and metabolic function. So pH is super important. We have to, the body needs the pH to be at a certain number. So this is the pH scale. Boom. It goes from 0 to 14. So the more hydrogen ion you have in the body, the more acidic you are. The less hydrogen ion you have, the more basic you are. I'll tell you about what that means later, but today, neutral is 7.40. Our blood pH is 7.35 to 7.45. Sorry, I messed up here. You'll see a lot of mistakes, but anyway. So that's why pH is important, and this is the blood pH, normal blood pH. Second component, CO2. So CO2, super important and very intricately related to the respiratory system. Meaning the respiratory system, every time we have any metabolic function at the cellular level, CO2 is our waste product. So we have to breathe it out. The way we breathe it out, the way we rid of it, is by using the respiratory system. So there are many processes in our body where we need to breathe fast to get rid of acid. I don't want to tell you any of those right now because I do not want to confuse you. What I want to tell you is this: if you start breathing too fast, you're gonna get rid of a lot of CO2. If you start breathing too slow or not breathing at all, then it accumulates in your body, and that leads to acidosis. So these are the normal levels of CO2, 35 to 45. The more you have, the more acidotic. The less you have, more close to basic, okay? Now bicarb. Bicarb normal levels are 23 to 26. Different hospitals might use different numbers, but we're gonna do these two. They are pretty standard. So bicarb is produced in the kidneys and in the pancreas when there's acidosis going on in our bodies. However though, this system takes forever to engage. So when the body is trying to compensate for any metabolic or alkalosis condition in our body, we use the respiratory system first. For example, DKA. DKA is a condition where you have acidosis. Diabetes ketoacidosis. The word acidosis is in the word, so you have acidosis. So if you have acidosis, it takes the kidneys a long time to make bicarb. So what the respiratory does, it starts breathing really fast to get rid of, to decrease the acidosis. Remember, CO2 is an acid, so that's the connection I make. It doesn't really work for DKA. That's a different really complex condition, but what you have to remember is this: you breathe fast to get rid of CO2 in an effort to try to decrease the acidosis caused by DKA. Remember, Kussmaul's respirations kind of thing? Perfect, so you got that? Perfect, let's move on. So these are the three components: pH, CO2, and bicarb, and I gave you the normal levels. That's the number one thing to know on ABGs. So how to interpret ABGs? Well, I use the ROAM acronym. A lot of people use it and a lot of people explain it, but explain it wrong or in an incomplete way. What do I mean? So the acronym, the little mnemonic, this is respiratory opposite, metabolic equal. But what do they mean? Well, they mean that when the pH and the CO2 move in opposite directions, like this, it's caused by a respiratory issue. And when the pH and the bicarb move in equal direction, either up or down, it's a metabolic. Kind of hard to explain, so let's apply it. But before we apply it, what I want to tell you is how to get this systematic approach. So this is my system. This is my system, totally mine. So the first thing we do is when we are given an ABG, which I'll give you one, see I have examples ready. When we're given an ABG, we look at the pH first. If the pH is below the normal levels that I already told you, boom, boom, it's said to be either alkalosis or acidosis. So the first thing we look at is that pH level, and that's going to give us the answer to see if it's alkalosis or acidosis. Second thing in my system, if the pH is with the normal limits, it's said to be compensating. If it's not, it's uncompensated. So if they show you a pH of 7.38, it's compensating. 7.39, it's compensating. 7.32, uncompensating. 7.48, uncompensating. Got it? Perfect. Rule 3. Here's when we apply Rome. And we do that by adding some arrows up and down in our thing. I'll tell you how I do it. Looks like a lot. It's super easy. You're halfway there. So I'm going to give you 3 examples. Before I get there though, I want to tell you that advanced practice practitioners, providers, they use this thing right here. This is called fishbone or skeleton. The skeleton, the first number, because they don't give you the letters, they just tell you what the values are. So if you see a skeleton like this, the first value is pH, the second value is always going to be PaO2. Third one is first volume is pH, second volume is PaCO2, and then PaO2, and then bicarb, and then base excess, and then oxygen saturation. So for today, we don't care about this one, we don't care about this one, and we don't care about this one. We care about these 3, right? Boom. So now, first example of the day. This is the ABG that respiratory therapist handed to me. So now I have to interpret this. Boop, boop. So anyway, so we look at the pH first. This pH is below 7.35. So we already know right there that the pH is acidotic. Boom. Second thing, the pH is out of normal ranges, so we say that it's uncompensated. Now 3. For 3 we apply Rome. So how do you apply Rome? Very easy, by putting simple arrows up or down. So we're gonna compare these values to the normal values. And if they are going up, we're gonna do an up arrow, and if they're going down, we're gonna do a down arrow. Pretty simple. Let's start with pH. So pH is 7.30, it's low. PaCO2 is more than 45, so it's high. We don't care about that. And this is 29. We're gonna say 24. This is 24, so therefore it's normal. And this is base excess, we don't care, and saturation, we don't care. So now look at the arrows. We're gonna look at the relationship between pH and PaCO2. Well, they are moving in opposite direction. If pH and PaCO2 are moving in opposite direction, it's opposite respiratory, Rome. Respiratory opposite. So now I know, well, then I check the pH and the bicarb. So bicarb is neutral, so there's no movement there. So I know for sure that this is a respiratory problem. So now, once you finish the 3 steps, then you name the ABG. This is an uncompensating respiratory acidosis. Boom, too easy. Now, I'm gonna give you another one. So, rule number one, we look at the pH. pH is also acidotic, so we're gonna say is acidosis. Rule number 2. The pH is out of normal ranges, so it's uncompensated. And rule number 3, we're gonna do a little arrows. This is moving down. This is normal. Now there's a change right here. This we don't care. And this is moving down. So now I know there's no relationship according to the Rome rule, which is right there. According to the Rome rule, one of these needs to be wrong, right? So on my example, this is, we can't use this one because the PaCO2 is normal. But now we're gonna check at how these two are behaving. So these two are moving down. So when they move in equal directions, it's gonna be a metabolic issue. So 3, metabolic. So now we can name it. It's an uncompensating metabolic acidosis. Boom. So now let me give you a harder one. So this is the skeleton that we're given. I already told you we don't care about this today, we don't care about this today, and we do not care about this today. So now, rule number 1, let's look at the pH. pH is within normal limits. See, 7.36, normal limits. So, let's go back to this. I told you that complete neutrality is 7.4. Well, this one is within normal limits, but it's on the acidosis side. So even though it's normal, we're gonna say that this is a little acidotic. It's still acidosis because it's below 7.4. So we're gonna say acidosis. Rule number 2. The rule number 2 says that if the pH is within normal limits, we say that it's compensating. So now, rule number 3, Rome, arrows. So this is moving down. We already established that. This is moving up, and this is moving up. Man, everything is changing. See how everything is changing? Boom. So now this is changing. The changes that we are seeing in a ABG like this is because one of this is off, and the other one is moving in the opposite direction or the same direction to try to compensate. Okay. So what we are looking at here is a huge acid-base issues with compensation. So now this is where Rome becomes more useful, because now we're gonna compare this one and this one. Rome. So remember Rome. Respiratory opposite between pH and CO2. Now let's look at this one. Metabolic equal. So bicarb and pH are moving in opposite directions, so the rule does not apply for those two, but does not apply for bicarb and pH, so it's not metabolic, but it does apply to pH and PaCO2. So here we're gonna have a respiratory issue. Okay, so boom, now we can name this thing. It's a compensated respiratory acidosis. Now, there are times when the body is compensating but it's not quite there. For example, let's say we have the same numbers, but this one it's 7.34. Okay, we're gonna follow the same steps. The pH is below 7.35, so it's acidosis. I mean, it's below 7.40, so it's acidosis. And if you notice, it's out of normal ranges. So anyway, if it's out of normal ranges, we're gonna say that it's uncompensated. Okay? So now we do a Rome. But see how everything does not match? Now, because we have these changes, on this one we saw how the CO2 is increasing, the PaCO2. And this one is increasing as well, but it's going in the opposite direction of the pH. So the Rome rule, like we established before, does not apply for the metabolic portion. So we say, because this is changing and because this is moving towards the normal pH, 7.35, we say that this is not compensating, but partially compensating. So now let's look at our arrows again. Down, up, down, up. So it's not metabolic because it's not equal. It's still respiratory. And this one we're gonna say partially compensated respiratory acidosis. The partial compensations are kind of hard to explain. What I would like you to focus on is to catch the other ones. I want to do something. I want to give you another one here, and I'm going to ask you to text me or type below here in the box, that way, the answer. So if you had a pH 7 point, bam, and then you have 30, and then you have PaO2, and then you have, we're gonna say 23, and then base X's we don't care, and this last one we don't care. So try to interpret this one, okay? And let me know what's up. Text me or write it down in the comments, the comment section, and let me know what's up. I think this is kind of simple, and that tells you how to interpret the ABGs. Interpreting the ABGs is not hard. What's hard is trying to find out what's causing the issue, which I can tell you about that some other time. For now, we're done though. Thanks for listening to me, and I hope it works. Let me know if it does.